Good afternoon, scholars. In part 2 of our lesson about percent composition, I'm going to show you how you can use percent composition as a conversion factor. In other words, how can we use percent composition to solve word problems? In our first example, we read, the pie chart shows the percent composition of sucrose. What is the mass in grams of oxygen in a 340.67 gram sample of sucrose? I want to remind the student that if you see gram per gram in parentheses, that tells you that this percent is by mass. First thing we want to do is identify what information we're given and what information we want to find. We are given a 340.67 gram sample of sucrose, and we're asked to find in grams the mass of oxygen. Start with a picket fence, 340.67 grams of sucrose. I'm going to write grams of sucrose diagonal in the next fraction. Then I'm going to put what I want up top, and that is grams of oxygen. Now it's important to know here that the oxygen is just an O, not O2, and that is because oxygen is part of a compound and not by itself. In other words, it's not diatomic here. So we need some type of ratio that relates the amount of oxygen to the amount of sucrose, and we have that relationship with percent composition. Remember that the percent is a part of the whole. The whole part, that represents 100% of sucrose. Oxygen's part is 51.41% of that whole. So to get our conversion factor, all we're going to do is take our percents and change them into grams. So now we see that for every 100 grams of sucrose, there is 51.41 grams of oxygen. Multiplying by our numerators and dividing by our denominators, we see that grams of sucrose cancel out, and we're left with grams of oxygen. That's what we want. So we punch this into our calculators, and we get for our answer 175.14 grams of oxygen when rounded to the appropriate number of significant digits. In our next example, we are told aluminum sulfide contains 35.9% aluminum by mass. How many grams of sulfur are in a 23.1 gram sample of aluminum sulfide? So the information given in this problem is we're told that aluminum sulfide contains 35.9% of aluminum by mass. We are also told that the sample of aluminum sulfide has a mass of 23.1 grams. Using this information, we are asked to find grams of sulfur. For this type of problem, the student might have greater success if they visualize percentages of this compound using a pie graph. According to the problem, 35.9% of aluminum sulfide is from the element aluminum. If the compound aluminum sulfide represents 100%, then what is sulfur's percentage of this compound? Well, we know this compound is only made up of two elements. And one of those elements is aluminum, and it contributes 35.9% of the overall mass of this compound. So if I subtract that from 100, I get that the percentage of sulfur in this compound is 64.1%. With the percent composition of sulfur in hand, I can now begin to solve the problem. Let's start with a picket fence, put my given of 23.1 grams of aluminum sulfide in the upper left quadrant. To get rid of grams of aluminum sulfide, I will put it diagonal in the next fraction, and I'll put the unit that I want up top, which is grams of sulfur. Converting my percentages to grams, I see that for every 100 grams of aluminum sulfide, there's going to be 64.1 grams of sulfur. Multiplying by my numerators and dividing by my denominators, I see that grams of aluminum sulfide cancel out, and I'm left with grams of sulfur. Punching this into my calculator, I get for an answer 14.8 grams of sulfur when rounded to the appropriate number of significant digits. Finally, in our last example, we are asked to calculate the mass of carbon in 120 grams of propane, which has the chemical formula C3H8. In this problem, I'm given 120 grams of propane, and I'm asked to find the mass of carbon. I'll begin with a picket fence. I'll put my given in the upper left quadrant, 120 grams of propane. I need to get rid of grams of propane, so I'm going to put it diagonal in the next fraction. And since I'm asked to find mass of carbon, I'll put grams of carbon up top in the numerator. So to perform this conversion, I've got to get some ratio of grams of carbon to grams of propane. I can find that by calculating the molar mass of propane. In this compound, I see carbon and hydrogen. There are 3 atoms of carbon and 8 atoms of hydrogen. Next, I'll multiply these numbers by the element's atomic mass according to the periodic table. Now I see in this compound that carbon's part is 36.03 grams and that hydrogen's part is 8.064. If I add these together, I get a total molar mass for the compound of 44.09. Calculating the molar mass of propane, I now see the ratio of carbon in propane. So in my picket fence, I will put down below with propane its molar mass, 44.09. And in every 44.09 grams of propane, there's 36.03 grams of carbon. Multiplying by every numerator and dividing by every denominator, grams of propane cancels out, and I'm left with grams of carbon. Punching these values into my calculator, I get for the mass of carbon as 98 grams. The student will notice that even though we do not have the percent composition of propane given to us in the problem, we can still use the concept of percent composition to solve problems like these. That concludes today's lesson. For my internet audience, if you have any questions, send a message to my YouTube channel. For my students, write down any questions you may have and bring them to class. Thank you for watching and have a great day.